Hello everyone, this is Revati working as an assistant professor in the Department of Information Technology from SNS College of Engineering, SNS Institutions, Coimbatore. In my today lecture series, we are going to see about a routing algorithm which is having two types. First one is unicast routing, another one is multicast routing. Unicast routing means it will direct from one to one relational. Multicast means it will use the concept of broadcasting in the networking. Let's we move on to the topic. Here, there are three types of routing algorithms are there under the unicast routing algorithm. First one is distance vector routing. Then second one is link state routing algorithm. Third one is the path vector routing algorithm. In this video, we are going to see about a distance vector routing algorithm. And distance vector routing algorithm uses the concept of Dijistra's algorithm, which is from the data structures. Let's we move on to the definition and example of the distance vector routing. Here the definition of distance vector routing is nothing but here each node creates its own least cost tree with the information it has about its immediate neighbors with the corresponding distance also. Denoted in the table. That table is called the routing table, and this method is introduced by the Bellman-Ford. It is called as the Bellman-Ford algorithm. The incomplete trees are exchanged between immediate neighbors to make the trees more and more complete and to represent the whole internet in the network. And here the Bellman equations are used. This equation is used to find the least cost between a source and destination node. Here the source will be considered as X, then the destination node will be Y. This algorithm will used to find out the distance from X to Y. The X will be any other device or system which is available in the network, and also Y is also any other device or system which is available in the network. Here the explained the working principle of distance vector routing. Here each node in the internet when it is booted creates a very distance vector with the minimum information the node can be obtained from its neighborhood. The node sends some greeting messages out of its interfaces and discovers to identify the immediate neighbors and the distance between itself, and also how to find out the each neighbors on the corresponding node. It then makes a simple distance vector by inserting the discovered distances in its corresponding cells. Here, the each node creates its vector. It sends a copy of the vector to all its immediate neighbors, and a destination node receives a distance vector from a neighbor. It updates the distance vector using Bellman-Ford equation. Here is the example for distance vector routing algorithm. In this example, we are having seven nodes, named as A, B, C, D, E, F, and G. Have to find the initial routing table and the final routing table for each and every node which is present in the network. Here the A routing table will be A immediate neighbors are B and D. So the distance will be denoted directly in the routing table, and there is no direct link between other nodes in the network, that will be denoted as infinitive. Then B is having uh, three immediate neighbors, so the distance of three nodes will be denoted directly in the routing table, and the other nodes entries are infinitive. Then here C routing table will be A is infinitive, B C to B is 5, C2 D, there is no link, that will be denoted in infinitive. Then C2E infinitive, then C2F is 4, then C2G is 3. Then D nodes are having two neighbors, that is A and E. That entries will be denoted in the table. Other entries are denoted as infinitive. And E is also having three immediate neighbors. That distance are mentioned directly in the nodes, directly in the routing table. Other distance from the E nodes are denoted as infinitive. Then F is having three nodes as neighbors named as C, E and G. That distance will be denoted directly in the table, and other distances are infinitive. Then G is having two immediate neighbors, they are C and F. So that distance will be directly denoted in the table. Other entries are denoted as infinitive. And the final state will be here. For example, I will take node B. New B will be 2, 0, 5. D2, B to D is 5, and E to B to E is 4, and F is infinitive, G is infinitive. Here the new distance will be D to B2. Yeah, you can reach the D node and D node using A as the intermediate node. So B to A is 2 plus A to D is 3. Likewise, you can reach the D node through the E node. But the distance will be higher than the intermediate node as A. So you can take the least cost path from B to D. That is the new distance from B to D is 5. Likewise, how to calculate final routing table for each and every node present in the network. Thank you for watching. And the disadvantages of distance vector routing will be count to infinity. The finding least cost will be taking very long process. Then split horizon will be arrived during the distance vector routing. Thank you.